Okay, continuing on with our Meto series of videos, we're going to look at disease models for corn. The biological factors for this disease, the disease development, the fungus is dependent upon the environmental conditions, of course. We'll look at that. It's assumed that the host and the pathogen are present at the same time in the region. Plant disease results only if all the factors occur at the same time. So if you have a newly emerged disease in the region, the inoculant levels will be far too low for that pathogen to cause a disease outbreak. The disease triangle really shows this. We have the host, the environment, and the pathogen. The environment tips the scales in favor of the pathogen to overwhelm the host defenses, and it leads to a disease outbreak. So we need to know the environmental conditions at the field. What are they? You have to have in-field stations, site-specific for temperature, solar radiation, relative humidity, leaf wetness, precip, soil temperature. Those are some of the variables that are required for different disease models. So we'll be looking at the gray leaf spot on corn and the conditions for it in terms of the environment that lead to a outbreak. So one thing that has to be recognized is the importance of localized weather data. We can't have weather stations that are 10 kilometers or more from a given field. They just aren't close enough to make a disease model work. And that's shown here where we have a station that's only 1.5 kilometers apart. One at a main office under grass, one actually in the canopy, and we can clearly see the difference between the two models, the sensitivity of the model to the local environment. Here we see a lot longer extended period of disease development and risk and pressure under the crop, whereas at the main office we see a very short period for pressure risk of the disease. And that's governed by the local humidity and lack of leaf wetness periods, whereas at the field we see higher humidity and longer leaf wetness periods. So when you look at a disease model, you need to really have that local data in field and look at the geography of the area and design it based on your customers' needs. So in terms of the corn production disease risks in FieldClimate, we have three models. We have a Fusarium head blight model, we have a leaf blight model, and a gray leaf spot model. We all know it's the genetic traits that set the ultimate yield of a crop, but it's the conditions through the year that limit that in terms of moisture, insects, and in our case, we're talking diseases. So there is a value proposition for corn disease models, and in fact for the gray leaf spot in FieldClimate, a good one. We have with local weather data that we collect off our stations, like humidities and leaf wetness and precip and temperature, we'll know the modeled conditions for the disease risk. We can time then our fungicide applications based on the actual conditions and disease risk pressure in synchrony to the crop stage. We can then preserve our yields based on a well-timed fungicide application or applications, which becomes we are efficient in what we're doing in preserving our yields and maintaining our crop health for proper yield potential. So the corn disease model for gray leaf spot, the fungus does survive over the winter in infected residue on the soil surface, and with increasing temperatures in the spring, spores are produced on maize residue and splashed to the young leaves through rain and wind. And that's the reason why symptoms are commonly observed in the lower leaves of the plant first off and then transported up as the crop grows. So ideally, this disease needs good humidity, high humidity, 90% or more, and temperatures of 24 to 30 degrees Celsius to develop. So the development of spores will decrease under lower humidity conditions, but then can reinvigorate again under the proper higher relative humidity conditions. So it's an opportunistic disease which can carry on throughout the year based on the environmental conditions changing. So you have to pay attention to that. So due to the length of the infection process, though, symptoms may not be seen for some weeks after an infection event, depending upon the weather conditions and the hybrid susceptibility. So looking at the actual model in FieldClimate, we see the corn model, we see the three models we talked about, highlighted the gray leaf spot. We see the risk level here on the top graph increasing and decreasing, and that's governed by the temperature and humidity over a period of time. And you're looking at for the length and duration of the period as well. So we see in FieldClimate that we model this based off temperatures 22 to 30 degrees Celsius and humidity greater than 90%. And the risk will range from 0, being nothing, to 100%. And it's your comfortability of which risk you want to assume. Do you assume a 60% risk or 80 or 100%, and the length of risk where I will make an application. The other point we talked about is being very aware of the synchrony of the disease in relation to the growth stage. So growth stage of V4 to V12, vegetative 4 to 12, is very important for this disease. And we can use growing degree days to calculate our growth stage using our growing degree day calculator in FieldClimate as well. So now we can look at the synchrony of that field in relation to the disease risk. So we look at it a little more detail. We break it in and look at some dates. We can actually see very quickly a risk rise rapidly here because of ideal humidity conditions and temperature conditions. And then we have a sustained period of risk at a fairly high level, up to 80% risk. And that's again because of that local data from your station. The humidities are ideal and the temperatures are ideal. So in here, we may be wanting to think about, if we're at the right stages, to apply an application of fungicide. And then the control period, of course, is based on that product label and may need to be reapplied if another infection event occurs. So for gray leaf spot, there is quite a cost benefit. We know that this has a significant impact on yield based under the favorable weather conditions and the right stage of development. And the lesions can really affect a plant because they work from the bottom up, the lower leaves up the plant, and they rob the plant of the photosynthetic capability to produce carbohydrates that lead to grain yield. So the yield loss can depend upon the number of lesions and how far they've really reached into the canopy up the plant as the plant enters the tasseling and pollination period, which is important for yield set. So if the lesions have reached the ear leaf or higher during 2 weeks before tasseling, you can have a significant yield impact because of this particular disease. So it's often estimated the corn yield loss based on the percent of infected leaf tissue by early dent. So we can have 5% up to 100%. And the yield loss of that is anywhere from 0 to 2% up to 15 to 50% yield loss. So you may consider a fungicide application if the hybrid is rated as poor or susceptible or moderately susceptible, and 50% of the plants in the field have disease lesions present on the third leaf below the ear leaf or higher prior to tasseling. That's one. Two, the same thing is rated moderately poor or moderately resistant, and 50% of the plants in the field have disease lesions present in the third leaf below the ear leaf prior to tasseling, and the conditions going forward don't look that good as well, in that the weather is unfavorable. So if you pencil this all in as some examples of using the average corn yield of 175 bushels per acre at a 12.5% yield loss or 50% infection, we would lose 22 bushels an acre, or about $110 an acre. Is a substantial amount of money. Even at a lower yield loss, a 7.5 bushels an acre, 15% infection level, we would lose about 13 bushels an acre, or $65 an acre. So we could lose on 1,000 acres of corn $65,000 to $110,000, which is a lot of money if you consider it may cost you $3,000 for this IoT investment for a field station, and it's returning more than 14 to 1. So actionable tools and on-farm sensors provide value through the entire year, not just at one point where we're looking at yield loss because of agronomic issues. It also improves things like looking at soil moisture for optimal yields for the crop. So we can improve our yield outlook by having better tools throughout the entire growing season to optimize our cost of production per acre. So the benefits from here, you really know, and before you go, you save time and money before you go to the field to know if you should spray. You verify field weather conditions because you have an in-field station. You know the verified model infection conditions, the severity of the infection, and you can determine the timing of the spray, the date and hour from the model, as well as know if it's a good time to spray based on our spray cast models as well. And you have a record of past infection levels and weather conditions for the field. Thank you.